All right, so continue on in the same section. We're going to talk about the derivative. And derivative is something you guys will be calculating or finding in most of calculus. Okay, so the first half of calculus is computing derivatives, second half is really computing integrals. And so what I'm about to give you is the limit definition of a derivative now that we've gone over the slope of a tangent line. And let's just kind of read this definition here. The derivative at a point x comma f of x is given by f prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x all over h. And if you take a look at this, right, again, this reads f prime. Okay, that's how you would read it. Okay, so this little apostrophe here reads f prime of x. This is something you've seen before, right? And so if this is my f prime, this is the definition of a derivative at a specific point. The derivative, f prime of x, really is just the slope of your tangent line, right? This is just your m tan, right? So if you go back and look at the notes that I wrote over here, right? M tan is just the limit as h goes to 0, f of x plus h minus f of x all over h. I have that m tan expression over here again, and that is just f prime of x. Okay, so that's the connection. The slope of the tangent line is the, this is actually called a first derivative. Okay, so in calculus you'll learn second derivatives. And that's the definition, okay? The limit definition is basically f prime of x is the slope of your tangent line, which is this expression right here. There's some other notations that you might see for derivatives, just FYI, d dx of f of x, okay? This is also the first derivative. You might see dy dx, and you also might see y prime, okay? But for now, just read, this reads f prime of x, this expression you've seen before, which is essentially the slope of the tangent line. And of course, this expression right here is the slope of the secant line. But once you take the limit as h goes to 0, the slope of the secant line, it becomes the tangent line, which is f prime of x. Okay, long story short, the definition of a derivative at a point is basically the slope of your tangent line. Okay. All right, so let's take a look at another example. It says find the derivative of the function. Use it to determine where the tangent line is horizontal. All right, so here's my f of x, and I want to find f prime of x. How do I find f prime of x? I'm going to use this limit definition of the derivative, right? The limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so again, first derivative is basically the slope of the tangent line. And so I'm going to evaluate what this difference quotient is using this function, and then I'm going to plug in h is 0 at the end. Okay, so again, using your limit skills, let's plug in. This is the limit as h goes to 0. All right, if I want to plug in x plus h into the function, I'm going to get negative 3 x plus h squared minus 6 times x plus h, and then minus the function itself. So you got to be careful here. There's a negative 3x squared minus 6x. Okay, so this is the kind of work that I expect to see when you guys, submit your homework quiz. Show all the work. Don't neglect any steps. Okay, oftentimes if you look at the solution manuals, they skip a lot of steps. So just kind of follow along what I do here in the video, okay? All right, now, this problem becomes a limit problem, right? You're going to have to simplify the numerator, and then eventually the h has to cancel out, right? Because if you plug in h as 0 right now, you're going to have 0 in the denominator, and if you plug in h as 0 in the numerator, you're going to get 0, so it's going to be indeterminate, okay? So you're going to have to FOIL combine like terms. All right, so just practice the algebra skills. Again, keep writing the limit as h goes to 0. So if I FOIL this, I'm going to get x squared plus 2xh plus h squared minus 6x minus 6h Distribute your negative sign. You're going to get positive 3x squared, positive 6x. All over h. Okay, and then keep going, right? Distribute your negative 3. Negative 3x squared, negative 6xh, negative 3h squared, minus 6x, minus 6h, plus 3x squared, plus 6x, all over h. All right, now take a look. Some of these terms should cancel out, right? Negative 3x squared, positive 3x squared disappear. Positive 6x and negative 6x, right? These guys disappear. And between these three terms right here, right, it looks like I could factor out, a negative h, or you could factor out a negative 3h. So it's up to you. Let's factor out a negative 3h. So if I factor out a negative 3h, what I'm going to have here is a positive h, positive 2, right? And then minus, positive 2 over here, positive 2x. Right, let's distribute to check our work here. This times this, negative 3x. All right, this times this will give us negative 3h squared. Negative 3h times 2 will give us negative 6h. And this times this will give us negative 6xh. All right, so if we cancel out these h's, we're going to get the limit as h goes to 0 of negative 3 h plus 2 plus 2x. Okay, so this very last line, right, it looks like you can plug in h is 0. So do that. If you plug in 0 over here, you're going to get negative 3, 2 plus 2x, which is the same thing as negative 6x minus 6. Okay, so this is my f prime of x. Okay, so all this equal sign right here, this is basically what f prime of x is. And this is the first derivative, right? Or this is f prime of x. And again, what does this represent? This represents the slope of the tangent line, right? The first derivative is basically the slope of the tangent line. And this will tell you the slope at any point on this particular curve. Okay, so what we've done so far is part 1. Or you can call it part A. F prime of x is negative 6x minus 6. And then for part 2, the question is asking, use this equation of the tangent line, or my first derivative, to find where the tangent line is horizontal. Now, where is the tangent line horizontal? So it'd be helpful to kind of do a quick sketch of this graph, right? So, I mean, you don't have to be super precise in finding the vertex. If I factor out negative 3 over here, 3x, I'm going to get x, plus 2, right? So the x-intercepts are 0, negative 2. So just a quick sketch. You don't have to be super precise. Here's 0, here's negative 2. I know the parabola is going to go down. And, if you really want to, you could use the vertex formula, but it's not necessary. Okay, so roughly, this is the graph of my parabola, right? And what is this? This is the equation of the tangent line. This is also the first derivative. And where's the tangent line? If I draw a tangent lines here, right, it would look something like this. It would look something like this. If I draw a tangent line here, right, at this point, it would look something like this, look something like this. But where is the tangent line horizontal? Right here at the vertex, right? That's where the tangent line would be horizontal. And when the tangent line is horizontal, right, m tan, right, if I ask you, what is the slope of the horizontal line? You would say it's 0, right? And so, to answer this question, use this to determine where the tangent line is horizontal. You don't say at the vertex, right? I mean, it's true at the vertex, but you got to be a little more specific, right? You set f prime of x, right, is equal to 0. That's where the tangent line is horizontal. Okay, so if I set f prime of x is equal to 0, 0 is equal to negative 6x minus 6. You're going to get 6x is equal to negative 6. and x is equal to -1, right? This actually is the x value of the vertex right here, right? So if you want to get the y value, right, you plug it in, f of -1 into the function. You're going to get -3, -1 squared, minus 6 times -1, and you will just get 3. Okay, so where's the tangent line horizontal? At the vertex. What did you do? You set f prime of x is equal to 0, because f prime of x represents the slope. And what do I set it? Why do I set it equal to 0? Because the slope of the tangent line, right, if it's horizontal, it has to be 0. So that's why I set this equal to 0. Okay, so 0 is equal to -6x minus 6. And -1 comma 3 is basically this coordinate right here. So -1 comma 3, and we basically just use calculus to compute the vertex of a parabola. And, you know, in the past, right, you would probably use x equals -b over 2a formula, or you could use the midpoint rule, right, 0 plus -2 divided by 2. That works as well. But now you're using some calculus, okay? All right, so let's move on to one more example here. It says, find the equation of the tangent line at the given point, graph the function and the tangent line. So let's start with a graph, right? The graph of this problem will look something like this. It's a parabola, and if I ask you, hey, what's the vertex of f of x? You would say it's 0, 1. And if I ask you the orientation of this parabola, right, you would say, hey, it's opening up. You could always plot some points, but I told you, right, I told a little trick to my students that if this a value is a nice integer, you can go quickly do a quick rise over run just for the first set of coordinates. So go up 2 over 1, up 2 over 1 to the left. Only if that a value is a nice integer could you do that, okay? And only for the first set of points. Okay, so there's my parabola, right? And so let's find the equation tangent line at the given point. So at this particular point, 1 comma 3, right? 1 comma 3, which is right around here. I want to find the equation of the tangent line. So if I were to draw a tangent line like this, right, what is the equation of that tangent line? Okay, so that's basically what the question is. And then graph the function in the tangent line. So we sort of already did that, okay? All right, so how do I find the equation of the tangent line? Well, I need the slope, right? I need the slope of the tangent line. And I already have a given point, right? The given point is 1 comma 3. And so once I have the slope, I could just use point slope, and then I'm done writing the equation of this line. Okay, so a little bit of algebra going back to, you know, all the way back to Math 1 or, you know, middle school days on how do I write the equation of a line. So all I need is the slope of the tangent line. Well, to find the slope of the tangent line, right, m tan is just f prime of x, right? That was the connection for this section. And you're going to have to use the limit process again. So let's do it. Let's do a quick review. Limit as h goes to 0 of f of x plus h. Again, the more you write this down, the more you'll have this committed to memory, okay? Over h. So let's evaluate. F of x plus h, if I plug in x plus h into my function, this is 2 times x plus h squared plus 1 minus the function itself. Now, when you plug in the function itself, make sure you put this in parentheses, okay? So oftentimes students just write minus 2x squared plus 1 without the parentheses, then they forget to distribute the -1. Draw those parentheses all over h. All right, so this one is not too bad. It's kind of like our first example on the previous page. Start doing a little bit of foiling over here. You're going to get x squared. In fact, I'm not going to show an extra line over here. You could just FOIL this here. X squared plus 2xh plus h squared, right? If you FOIL this. Distribute the 2. You're going to get 2x squared plus 4xh plus 2h squared. And then plus 1 over here, right? Minus 2x squared, minus 1. All over h. And a bunch of terms should cancel out, right? 2x squares will cancel out. The positive 1 and the negative 1s cancel out. Between these two terms, it looks like I can factor out a 2h. So let's do that. If you factor out a 2h, you're going to have a single h here, right? Plus 2x all over h. Okay, keep running that symbol limit as h goes to 0. These h's will cancel out, and all you're left with is the limit as h goes to 0 of 2 times h plus 2x. Now at the very end, right, you can plug in 0 into this expression. Once you plug in 0, you're just going to get 4x. Okay, so this is my slope of the tangent line. This is also my f prime of x, right? And the problem is not asking us to find the slope of the tangent line. It's asking us to write the equation of the tangent line. So this 4x, what does this represent? F prime of x is 4x. 4x represents the slope at any point on this graph, right? At this point, the equation is this. The slope over here, right? To find the slope at this point, you also use this equation. But I want this slope at 1, 3. Okay, so I just plug in f prime at the point 1, the x value of 1, into this expression. I'm going to get 4, and that's the slope at 1, 3. Okay, so if that's the slope, all I need to do is write the equation of the line, right? Y minus y1. My y1 in this case is 3. And my slope is 4. X minus x1, x minus 1. So I'm going to leave it in point slope. And just a quick note, those of you who are planning to enroll in Calc AB next year, when you're taking the AP exam, they don't really care if you write it in point slope or slope intercept. And oftentimes it's advised that you just leave it in point slope because oftentimes in a test, right, you're under time constraints, you're under pressure. It's very easy to make mistakes, right, to get y by itself, right? Sometimes you might just subtract 3 to both sides when you're supposed to add 3. It's okay to leave it in point slope. You don't need to simplify. If you want to check the answers in your textbook, right, they all leave it in slope intercept. So let's just convert it to slope intercept. This is your slope intercept, okay? Doesn't matter which form I put it in on the homework, it doesn't, okay? But in your textbook, it uses slope intercept. If you take the AP exam, AB exam next year, it doesn't really matter if you leave it in point slope. You don't have to simplify, okay? And the equation of the line, right, this equation right here is just y is equal to 4x minus 1, okay? So this little dashed line right here, you can actually draw a solid line now. And that's using calculus to compute slopes at specific points.